Alright, I guess I'm live. Yeah, I I should be live right now. At least in two of the platforms. I was trying to stream at Twitch too, but um I don't think um I don't think I am live at Twitch. I don't know why. I either I have to fix this and wait 5 minutes, or I will just solve few questions in 5 minutes. So I will just try to just solve few questions in 5 minutes, and after that I will just see if I can go live on Twitch for the very first time or not. I haven't streamed on Twitch uh, ever, so uh, I think I haven't set any output relocation from Twitch, so maybe that's why it could be a problem. Like, yeah, I don't know how to actually go live on Twitch, so I have to see some videos. All right, now never mind. We will just start doing linear algebra in the meantime. So hopefully it will be better. Yeah, I can't see any possible option to go live. I will just probably just see one video of how to do live on Twitch. After that, I will just do live at Twitch. Yeah, so uh, this is uh, image of my physical book that I am reading at this point of time. So we will start from, no, actually I opened this section. We can start from here actually. Yeah, we can start from here. After that I will go to uh, other chapter, which is determinants. Okay, so yeah, I am actually reading from physical book, so this is for just for reference for the live stream. So yeah, sounds good. So we can actually just go. um, yeah, I will be a bit quiet if I'm reading theory, and while solving questions I will just solve it in the screen too, in my OneNote. So probably this would be a better approach. But in the meantime I was still trying to do something on Twitch, but it didn't work. So I'm uh, back to square one. My bad, it's playing from Twitch only. So all right, no issues, we'll just go. I will just post this thing in Twitter. I did a lot of jargon here. Never mind, you can just start. Okay, I will keep my OneNote open. Probably here only. Wait a minute. I am not sure which of my screen was visible the whole time. Oh, okay. Bro, my bad. It's seriously my bad. Because I wanted to show the other screen, which was this one. Uh, but my other screen was visible the whole time. Um, okay, no issues, no issues. I thought that would be my main screen, so I don't know what the hell I streamed. Hopefully, I didn't leak any of my password, especially the Twitch one. So I am just hoping that, I don't know, I might have leaked my password. Oof, it's really complicated to do live stream sometimes. All right, so all set. I really thought I was just streaming this page, but instead of that, I was streaming the main, my other screen, other display. But no issues. Happens, happens sometimes. And I'm glad it happened at the time when I had like zero viewers. So cool. So first, I should just go back to this thing. So if I have to do the rough explanation, I will do it. And probably I will just make this most okay. Alright, I'll be just reading the thing now. Fine. So I will point my cursor over the part that I am reading, and when I read the other part of the book, I'll just put down my cursor sequentially. So that will be my approach. And I do hope my mic was on the time when I spoke. But if by chance my mic was off, then I will just repeat myself. I read this from read a line from here that if determinant is equal to 0, then and any of the determinant 1 to 3 is non-zero, then the system has no solution. That is, equations are inconsistent. And if any of the determinant is, let's say, 0, then the system will have infinite number of solutions. So we have to remember these three cases in case of solutions, because yeah, it will be useful. So yeah, these three cases are really important here. um this case 1, case 2, and case 3. All right. Basically I do have to come back um and revise this weekly, so that I can get a good grasp of things. I'll just mark it. And if I just go to the next page, so here we do have to solve from Cramer's rule. So where is determinant 1 and 2 coming from? I do need to figure out that. What is this determinant 1 and 2? I got the main determinant, so it makes sense. But where is determinant 2 and 3 is coming from? Like in this case 1 and 2. So for if we just go back and see this example, probably this example, yeah. So what's happening here? For determinant 1, the first row got replaced. For determinant 2, the second row got displaced by the solution, and for determinant 3, the third row got displaced by uh, by det- these vectors over here. Okay, so in the same way we can look this thing too, and let's just try to solve this. Okay, how it happened, why it happened, let's see for once, and then let's just try to solve this. So let's say we have uh, so it should work now. Yeah. So let's say we have x plus 5 equals to 4 and 3x minus 2y equals to 9. So what we can do here, we can create determinant 1, and that would be 1 2 3 minus 2. So first we have to just check if this uh, comes out to be 0 or not. If it isn't 0, then we can use Kramer's rule, which is, well, let's just see what's the Kramer's rule. Kramer's rule was determinant 1 by determinant equals to determinant 2 by determinant equals to determinant 3 by determinant. That's it. It was Kramer's rule, if I'm not wrong. Yeah. And in this case, we just have to take the condition that determinant, like the first determinant, shouldn't be equal to 0. So that's what Kramer's suggested. So I think I won't delete these pages, because here I am solving. So let's say minus 2 and 6. So minus 2 minus 6. Oh, did I put everything right? Okay, x y, this should be x y and this should be x y. Wait, what did it? X y and this should be x and y. Why I think it's something wrong. Okay, my bad. This should be 1. um this should be 1. Ask me why. Well, you shouldn't, but yeah. um okay, this is x and y, so this is x and y, right? And this is x and y for this. So first is minus 2, then we have 3, so minus 3, and it would be minus 5, so it isn't equals to 0. So we can use this thing, Kramer's rule. Alright, um we can move ahead with this. So let's say, for this is d1 d2. Okay, so this is d1 d2. What we have to do for determinant 1, what we can do, we can just replace 4 and 9 and keep everything same, and we will get our expression minus 8 and minus 9, so that would be minus 17. And we will have determinant 2, um, which will be 1 3 3 minus 2, wait, no, 1 3 and our d1 d2, 1 3 and 4 9, 4 9. So this would be 9 and 12, so minus 3. So if we have to find the solution, then Then this thing, determinant 1 by determinant. So determinant 1 is minus 17 by determinant is what is this? Should be equal to um uh this thing, minus 3 by minus 3 by determinant minus 5. This should uh, be applicable. So okay, we got our x and y from here, and let's say this will be our x, this will be our y, and also if both are negative we can just cross the negative sign, then these will be positive values. So x equals to 17 by 5 comma y equals to 3 by 5. Okay, that's it, I believe. So let's mark it as question 1 with probably a different color. Can I just choose different color? Like, I do want to use yellow. Why yellow isn't in the scheme of things? I want to keep yellow in the scheme of things. So let's keep this keep this yellow here. Okay, I can't even pick it, bro. Cool. Like really, it's cool. Question 1. We solved first question. Let's go. Let's jump straight to the second one here. So I don't know what's the next question. So again we have equation, and what this equation actually says, this equation have three variables: x plus y plus z equals to 9, and 2x plus 5y 7y 7z equal to 52, and then 2x plus y minus z equals to 0. And then here only we can use the Cramer's rule. So yeah, let's just see how we can apply it. Okay, so if we have these things in our hand, we can just use Cramer's rule. But I can see, are there something that we can do to cross the values? Because in the book I'm seeing there are some expansions uh, along the row. So I was just figuring out what we can do here. So here is one expansion, that first, for column 2, column 2 minus column 1. So let's create this into a matrix. Let's just create this into matrix like 1 1 1 2 5 7 2 1 minus 1. So this is our matrix. Sorry, determinant. um so I can see in the first, for the first thing, what we can do is we can subtract column 2 from, you can subtract column 1 from column 2. Okay, so that will probably That will probably gives us um, so first value would be, okay, let me just see what will be the first value. And even if we go from the first like the normal thing, then what will happen? I don't see there will be much difference. I mean, we will just make our way complicated if we just go and subtract things, isn't it? Like if I can solve the normal matrix fast, then I will just solve the normal matrix fast, because I don't think it takes more than a minute to solve a matrix. Or matrix or determinant, sorry, determinant. Why I say matrix all the time. Also, after that, we will do matrix multiplication, which is very important in all the AI modules, machine learning tools. They are matrix multiplications, so we will be doing that. Um, okay, so let me just first review why they are subtracting this thing, so that I can just get a like view why things are happening. Probably next Sunday we will also revise this thing, like in a more problem solving way. Like I will collect the problems from different sources from internet, and we will just use it in applied way, like how we can solve this. Okay, I don't know why it's happening and how it's happening, but let's just solve this matrix and finish it, man. Come on. uh, it's let's not make this complicated. So for this determinant, so if again I say matrix, so uh, -5 -5 -7, so -13 -13 this. um okay, I just figured out, if we just subtract the values from C2 to C1 and C3 to C1, then we can get 0 0 at y and z axis. So we just have to do uh, we just have to find the one matrix which is the same, which will be the same thing. Okay, it's actually a interesting approach. So let's just understand, this is the thing that we can do anytime, but the subtraction and reducing method, it does seem quite intriguing at first, but it really uh, help us to solve the question very quickly. So um, what is happening here? So for c2 we have to do c2 minus c1, and for c3 we can do c3 minus c1. So if we just minus these terms, then we can just get our values, such as uh, this is c2, and if it will subtract this, then let's say what will the value. So it should be uh, 146, correct? And if what actually we can do from, if we can just subtract c3 from c1, c3 from c1, so we just have to do the same actually, but it already became 0, so how we can just subtract it? Okay, I do think I want to go a little back and see how these things actually work, bro. Sometimes these things are complicated. Okay, I will try to learn it quickly because it's important. um so probably, okay, I couldn't find where these things were explained. um okay, let me just see the system of linear equation example, where they were applying these rules. So first, in the first term they subtracted here. I saw an example, I guess here, like here, see this example, or even we can just have a look on this only, and we can see how these things are working, like this one, example 30. We can also do this thing. So if we say from c2, c2 minus c1, c2 minus c1, so if we just take out the terms, okay, it's happening in column now. So for I just have to stick to basic principles and I can just do this. I messed up rows and columns this time, bro. I just Okay, I have to remember this is a row and this is a column. Okay, so if we are subtracting for column 2 from column 1, so what it would be? if we can just um this is column 2, this is column 2, this is column 1, then um okay, I am getting confused because if you see here, even if we subtract the things, like let's say we subtracted column 2, which is a bigger value. Let's say this is a mean matrix. We subtracted column 2. This is the same as ours. Like this is the expansion of this is in this determinant form. So let's see, if we are subtracting this from this, it would be 0, this would be 3, this would be 1, or yeah, this would be minus 1, 0, 3, minus 1. So why this value remains same? That's my doubt. If you are subtracting, then is it rule that this value will remain same? And for other thing, we just have to subtract this from this. So if we're subtracting 1 from 1, it would be 0, it would be 5, it would be, yeah, it should be, shouldn't it be positive 1? Like we are doing this now, minus 1, oh no, minus 1 minus 2, no, minus 1 plus 2, so yeah, it would be minus 3. Makes sense, finally I understood whole process, bro. I shouldn't have uh, taken this much time, but yeah, happens. Can't do anything, but I got to learn. Yay! That's the main thing. So what we can do, we can go over here and we can just do these things. So this value will remain same. I have to make a note over here only. This value remains same. I will keep this note. Finally we can do, I will just make a star over here. Okay, so let's do these things first. So for C2, if we subtract it from C1, so it would be, this would be 0, 3, and negative of 1. And for C3, if we subtract it from this number, then it would be 0, 5, and minus 3. And we'll put this as it is. So this is our matrix, this is our determinant in which we have to do the work. So if we just take the first uh, determinant, then it would be negative of 9 and negative 5, I guess, yeah. or, or will it be positive of 5 if I just do this? So we have to negative of 5, so that would be positive of 5, so we will do plus 5, so it turns out to be negative of 4, yeah. So if our determinant d determinant equals to this negative of 4, then we have to find, we just have to substitute our substitute our value of the solutions from to here to actually determine one. So can we again see what we can do over here? So let's say we have, not let's say, we actually have what's the solution. The solution, we have 9, 52, 0, and then again the same values, 1, 5, 1, minus 1, 7, 1. Now let's see what we can do over here. So uh, if we can plus these two numbers, so what it will be fetch, it will fetch us, it can fetch us yeah, these two will be 0. So we are just targeting to make two zeros wherever possible, so that we just have to do the equation in just for just one determinant. So if we plus these two, then this will be 0 and it will make sense. So for determinant, we can do on either side, but let's say for determinant 2, we will take c2 plus c3. So this value first, just let's just write this value. So it would be 2, 12, 0, 0, 52, 9, and then 1, 7, minus 1. So yeah, that would be it. Hopefully I'm not wrong. Okay, so we just have to go through this line. So if we are targeting minus 1, so we are going through this path, so we are taking minus 1 in account. So we have to calculate this 108 and 104. So 4 and then into minus 1, so it will be minus 4. So determinant 1 equals to minus 4. Now let's take determinant 2. I guess that was 2 only now. Determinant 2 into account. It would be a very long sum. Let's just not talk about speed now, because uh, this is the first solving. In next solvings I will just try to improve my speed too. So for 1, 2, 2, 9, 52, 0 and 1, 7, minus 1. So what we can do, if we can just double this up, if we can double this up and then subtract to this, would it be fine? um, I think it would be fine. Okay, let me see what they did. For this, and they are also doubling this up. Okay, they are okay. This is only now, so they are first doubling this up, then double this up, then minus from this, double this up, minus from this. So if I double this up, this will be minus 2, and minus 2 will yeah, minus 2 will cancel. Okay, let me just see once. So this is the case. Wait, would would it just cancel it? um okay, so what will be the value here? So it would be 14, right? So 14. Oof. I will just see what will the value say here, then we will just do this. So are we actually adding this or subtracting this? We are actually adding this. So that's how now we can negative this. So if we add this, then it will get cancelled out. Yeah, and it will be 14 plus 2, 16. Makes sense. This makes sense. So the approach will be um for C3, for C1. So first C1 minus, actually plus by 2 of C3. Okay, I think that's correct. Yeah, that's correct. So let's just do this. So uh, it would be 3. First just write the matrix: 3, 16, 0, 9, 52, 0, minus 1, 7, 1. So we will find this determinant by uh, this element. So so yeah, I guess we can just do this. um 52 into 3, 150, 156, if I'm not wrong. 156, 156 minus 16 into 9, is it 144? I think it's 144. So it comes down to 12. So that's 12 delta of determinant of 2. I hope I haven't made any mistake, else I have to figure out. And it will be a negative of 12 because we are eventually multiplying this too. So negative of 12. Yeah, negative of 12. Okay, let's just quickly do the last thing. This would be 122, 151, and 952, 0. So first we have to see what we can do. So in this case also I think we can just double this up, and minus, this time we have to subtract this. So to column 1 we have to do column 1 minus by developed column 2. Yeah, we have to do this. um, so for column 1 and 2, so if 18, 18, so it would be 17, it would be minus of 17. Okay, why it's then 1 here? Oh, my bad. It's we have to do this now. So 2 minus 2 minus 1. Actually, it's 1 minus 2, so it will be minus 1. And 10, so minus 8. And this would be 0. 0. And we will find the determinant by this element. So actually, yeah, by this element, so minus 1 into 52, so minus 52 minus 52 minus of minus 8 into minus 79, so it would be plus 72, 130, sorry, 120, 124. Oh, it's in negative now, so it's basically minus 20, or not, it's positive 20, because positive sign is created. Okay, I mess up a lot of times. Well, how it's minus 20, bro? How the hell is minus 20? Why do we have to do? Why this minus 1 is here? Isn't it plus 1? Isn't it plus 1? It is plus 1. So why there's a negative sign? I couldn't understand that. Maybe it's a printing mistake. So we will we'll just take this into account, because there's no way there, if we just have to multiply it by 1, because it's 1, right? But I'm missing out something. um I don't think I'm missing out on anything. So yeah, that the determinant of 3 equals to plus 2, so we can follow the Kramer's rule, which is d1 by d delta 1 by delta, determinant 1 by determinant, determinant 2 by determinant, and determinant 3 by determinant. So we got to know, so what are our values? um, can we select this thing? So I have to pick the, yeah, it's, it might be okay. This is r1 value, this is another value, this is another value, and this is a very important fact. We are brainstormed, unnecessary actually, but yeah. So we had our values like minus 4 minus 4, I guess. uh, Minus 4 minus 12, minus 4 minus 12, and what's the main value? It's also minus 4. So minus 4 minus 4 by minus 4 minus 12 by 4 and 20 by 4 by minus of 4. So this will be 1, this would be 1, this would be 3, and this would be minus 5. So that is x, y, z. Actually, in the book, it's all positive. Like for the last one, it's obvious because in the book it's written as minus 20. So okay, got this, but it was it was lengthy. I don't know how many minutes I took to solve only this. I will just see how many minutes gone by. Okay, it's been 1 hour and it took a quite good chunk of time. Okay, we can move to the next question. I read this question. This one. It is indeed a bit interesting. Um, I read it. I mean, the we just have to solve the equation here. So if the equation is given as it is, then here. Okay, let me read it once. Like how people are actually solving this. Okay, so we can just solve the determinant here, nothing fancy, but in the same way, way we don't even have to reduce or reduce or even multiply or add rows and columns. So yeah, we just have to solve the determinant and then see where we can apply the Cramer's rule, like for a not equals to 0, and for yeah, for like the basic for unique solution shouldn't be equal to 0. For infinitely many solution, the determinant and everything should be 0. All the determinant should be 0, and for no solution the main determinant should be 0, and at least one of the determinant should be non-zero. All right, I think we can move ahead with system of homogeneous equations. So what actually is a homogeneous equation? So we have multiple cases here. So homogeneous things I I'm like basically focusing on the things that I read on the MIT's portal. Oh, so yeah, I think we can double down on those topics specifically because that would be useful in main or machine learning modules and even probability. So yeah, yeah. After that also, I need to do some probability. So that would be fun too because the first lecture of probability was quite heavy, I would say. I don't know what's in my to-do list today. I wrote the to-do list yesterday. Um, Probably it's just one chapter. Yeah, just first chapter of probability. But the main spotlight would be this thing that we are doing right now, like solving questions here and there. Like we also have in MIT's website trivial and non-trivial solution. So what actually is this? So for trivial solution, the determinant shouldn't be 0, and I will just underline that in a book. The determinant shouldn't be 0, and x, y, z all should be equals to 0. So this trivial, and if determinant equals 0 and one of this is non-zero, then it's non-trivial. Okay, so that's the case for trivial and non-trivial. I was just reading some example over my book, so yeah, we can just move ahead. Okay, for once, I do want to check uh, the main MIT portal. We were solving the questions. I think we did solve some good problems. This was something which we needed to revise. Like, yeah, matrices are what's the main thing that we should study. So, okay, so matrix multiplication and I guess these two things are important. We did see linear equations, sorry, linear system of equations. So, yeah, uh, I think we should just go to matrix. Where is the matrix? Okay, in the PDF, I did inserted matrix at the top. So, okay, these are some shortcuts. I will revise at the end. So okay, so here is matrix. So what I inserted at top, no, it's determined only, so matrix is here. So here I uh, inserted three, I guess, yeah, three topics from matrix. First, the various forms of matrix, and then inverse, which is quite important. So yeah, I inserted it, and um yeah, we can just do this. After we have matrix multiplications, okay, we will see that. Okay, let's just focus on matrix here. And if we complete this within hour, I believe, till, yeah, I believe in 1 hour we can just finish it. And later on we will just have a look on bit of vectors too, like dot product, cross product, which are important. So matrix, it's from page number 605. Yeah, I am on the matrix page. So should we start from here? We can actually start from here. Okay, I was just trading a example of matrix multiplication because that's the thing that which is running our AIs. So so well, actually matrix multiplication uh, is quite easy. So we don't have to worry much about it. We just know how to do this. I think for I think I need to create a proper schedule. I did streamed very late today. I should have one more session where I just did solving, and for one more session I should do solving, and then I should be doing theory. Okay, so let's just solve matrix. After that, we can make a schedule to which I can just stick to. I do have a lot of time at night, um, but I have to see how do I wanna run it. Okay, um, let's just go to. Okay, there is a section, whole section for matrix multiplication which I haven't put in the PDF. So, I want to revise it. I will just put it in PDF in a while. So, I really want to revise this section because it's the core section, multiplication of the matrices. I put it from session 3. It is on session 1 only, but yeah, session 2 is kind of okay. But session 3, we do we have some um, good things to revise. Uh, we do have a shortcut for adjoint tool. Let's see what this shortcut actually tells about, because we do need a joint in case of the in case of what in case of inverse. We do need a joint so that we can divide determinant. We divide 1 by determinant into a joint, right? In case of inverse. So let's just see what is a joint, how we can just find the a joint. So here is the shortcut. Okay, I tried to understand this shortcut, and alright, it makes sense. If we are quick, then we can actually find a joins very quickly. But it's only applicable to the third order square matrix. Okay, the shortcut seems reasonable. So I will just mark this shortcut to revise. We will try to find one adjoint with this, at least one adjoint with this. So first we have to write down the 3 rows, okay, and first 2 rows, and first 2 rows, 3 rows of A. Okay, we will write 3 rows of A, and then first two rows. Okay, first 2 columns should be now. Okay, first 3 columns and first 2 rows. That should be the framing of the sentence. That could have been the framing of the sentence. Maybe it's incorrect. I don't know. So after step 1, rewrite first two columns. Okay, I can rewrite first two columns after this. um, I don't need to charge my device. I don't know why it's showing encoding uh, overloaded, because I'm not even playing uh, any video over there, so it shouldn't be showing any encoding problems. It's just my mouse, and if so, yeah, let's just see what we can do with these things. So after first step 1, write first two columns. So after that, we do have to write the first two columns. Okay, we wrote first two columns, all right. Then 1 0, and after step 2, deleting first row and first column, deleting first row and first column, and we will get the adjoint. Okay, this is kinda complicated, but like it's not complicated as long as we are writing the whole numbers, but it's gets complicated when we write only two rows, only one row, like only two row in the first thing, only two columns in the second thing. That's when it gets a little complicated. Okay, I will just fix the encoding problem in a second, because I think we can just fix the encoding problem by switching it to window capture to display capture. And okay, I can change the bitrate, but I think I inputted the optimal bitrate, so that shouldn't be a problem. Okay, never mind. So yeah, this thing is actually interesting. It's like we can go through this. We don't have to find uh, cofactors and all. Okay, there are actually a quite a lot of misprints here, but we will just move to inverse of the matrix, which is the important thing. I think let's just solve question number 34, example 34, and we will get clear with the concept of uh, this inverse of a matrix. If we can solve this, then we can just move ahead, because it's like directly inverse of the matrix question. So yes, let's just see if we can solve this. Let me first try it. Probably I do like this color, so um we can write inverse of the matrix probably. And we can go to this. So let's start. So if we have a determinant not, we have a matrix. We have a matrix 0 1 3 1 2 1 2 3 1. Okay, so this is it, and we have to find inverse of this. So first let's first find the determinant of this. If determinant isn't equal to 0, then we can just move ahead and find the inverse, and determinant equals to 0, then inverse doesn't exist. So just go 3 or 2, 2 minus 3. The first will be 0 anyways, so we don't have to calculate that. Let us calculate from the second one, which is obvious. Alright, we can calculate from the second one, and it moves from this order. Okay, so this will be negative, and from this direction, um so 1 1 minus 9, so that would be minus of 8, minus 8, yeah.